The people were at the end of the classroom could listen me, and it was physically very tiresome. I had small courses with 10 people or 6 people, so I have also these different experiences. I don't think that the ideal situation is when you have too many or too few students. The ideal classroom is about 20 people. 20 people interested in what you are saying. If you have 20 people who are not interested at all, it is a catastrophic situation.
So having talked about interest of students, how did you find the students here, the course that you taught? Or how do the students compare, how do the students in India compare to other probability students that you've taught?
I have done this course here in Indore, and there were some people at the end of the courses, you have noticed it, that at the end of the lesson came to me and asked for additional information. They discussed about some details. So I have this idea that some were genuinely and profoundly interested in what I presented. Some people who were in the far rows, I think they were not so interested. But this is usually everywhere. There are people who think of themselves or speak with the students which sits, yes, and I don't think there is a big difference. Since I have not made the exams, I cannot judge how profoundly they have studied in India. I have had other experiences. One is in New Delhi. I visited the Indian Statistical Institute in New Delhi, 2005. I remember that I delivered a talk. It was not so successful, according to my opinion. A second talk was in Chandigarh. It was a little better. And the third talk I delivered was in Jodhpur, in Rajasthan. And I remember very well that some people were profoundly interested, knew my results, my papers, and Professor Saxena, which you certainly know, told me that he appreciated very much some of the results, so I was happy about that talk. Here I had a talk in IIT, Indian Institute of Technology. I spoke more than I had, because I spoke 1 minute, I was told by Aditya. Some people were interested, some other people, as usual, are not so interested, but this is a normal fact. It is impossible that when you speak of mathematics, all the people attending your talk understand what you are saying and appreciate what they are saying. So I'm ready to this. In some other cases, for example, in China, people are forced to come to lessons, forced. So you have hundreds of people, but it's obvious that 90% of them do not understand English, do not understand mathematics, so because they are forced to attend. This is my personal experience.
So, sir, since you have written so many papers, like over 180 papers, so what was the one paper, like one of the things that of the part of your research that you really liked and it's close to your heart?
I don't. I can say that something depends on how well you speak in the language you use. For example, if I speak in my own language, in Italian, of course I am more effective than if I speak in English or if I speak in Russian, languages which I know. But if you are profoundly interested in what you say, I think that people can nevertheless understand what you are speaking about.
So was there any specific research that you started with on a note that it's really exciting to research in that field, or any particular topic that you still have that you still are really excited about to learn more?
This is a good question. For many years of my life, the most interesting field of research were random motions at finite velocity. Random motions at finite velocity. And I devoted to this topic of research many years and many papers. But I noticed that the interest of the other people to my specific research was not so big. And I started then changing a little bit to fractional calculus and the interplay between fractional calculus and stochastic processes. And the interest in this field, as you can witness, is by far bigger than for random motion at finite velocity. I was also interested in fractals and random motions on fractals, but it was necessary to spend many years of my life studying all the literature, understanding profoundly what is going on, and I had not the time. Then non-Euclidean spaces, which at a certain moment of my life I met randomly, and I think that everybody should know what is non-Euclidean geometry, what has been the meaning of non-Euclidean geometry, because the universe is not Euclidean. It's not Euclidean. And so people should know this, that at a certain moment of our civilization, of the mathematical development, you type of geometries which are suitable for better understanding the reality around us. So it was a part of my, when I started working at the university, I didn't know what to do. And nobody told me what is the type of research usually mathematicians should do. And it was looking through the specialized journals and meeting other people, participating to conferences, that I understood what people expected from me. And colleagues who told me, this is important, this is not important, this is very important. This was extremely useful for my further research.
Did you end up following that? This is important, this is not important?
In a certain sense, yes or no, because I follow my personal taste. There are things which are considered very important, but if I dislike them, I didn't follow them. But I always appreciate if someone tells me, consider that this as important developments. It can be applied in many fields. This has scientific consequences which you cannot even imagine. Maybe in 10 or 20 years, these things will become extremely important. This happened with fractional calculus. In fractional calculus, I remember this fact, maybe it is interesting also for you. I visited in '92 the Kazan University in Russia, and someone told me, I have shown a reprint of my paper, and someone told me, why don't you replace this derivative of order 2 with a fractional derivative of order 3/2? I thought at the time, in Russia there are many people drinking, so he was a drunkard, and he proposed to me something which is impossible. When I returned home, I told to my colleagues, you know, in Russia, there are people speaking about fractional derivatives. I never heard in no books that strange things. And many people laughed. I didn't know that in Italy, one of the creators of fractional calculus lived 100 meters from my department, Caputo. So some years later, I understood that I missed an important opportunity to start immediately being interested in this field. And only 8 years later, I started studying fractional calculus, understanding that it's possible to apply to many stochastic processes. This is a small fact that I had the opportunity. I didn't understand how important it was. I could be by far one of the founders, but I missed this opportunity. So I think that it is important to look around, hear the opinion of many people, above all of those who are very creative. Which have ideas, new ideas, not those who repeat all the time or think that the world is already traced and nothing can change.
So speaking of the creativity, so what area, like you have traveled a lot many places, so like which of the place did you like most, and like
Places?
Yes, sir.
Places from the university point of view or from the point of view of tourism? Both. I can say this, when I was very young, of course I live in a country which is considered the most beautiful, at least in Europe. So I was surrounded by beauty and interesting places. But the first country which I visited and struck me very much was France. And I started visiting France in all possible ways, also by bicycle. I made 9 long travels by bicycle through France. I visited all castles, churches, museums of France. Everywhere I have been. But at a certain point of my life, I met Russia, and from that point on, I ended up bigger than France. There are many interesting places, and the center of the world is Asia. The conclusion of my numerous travels in the world is that Asia is the center of the world, because 2/3 of the humanity the mankind live in Asia. All the most important religions have appeared in Asia. Many civilizations have their roots in Asia, Middle East, China and India.